Welcome back to part 3 of chapter 2, lesson 3, relating fractions and decimals and percents. You can use place value reasoning and equivalent ratios to write decimals as percents and fractions. A decimal with a last non-zero digit in the tens place can be written as a fraction with a denominator of 10. So for example, they gave us, let's zoom in a little bit here, 0.7, which is also known as 7/10. Well, to make 7/10 into 100, all you have to do is put a 0 on top and bottom. Essentially what you're doing is you're multiplying the top number and the bottom by 10. 7 times 10 is 70, 10 times 10 is 100. But we do allow you in math to acknowledge the fact that you can just put a 0 on the end of both and it doesn't change the overall value of the problem. So now we have a ratios comparison of some number to 100, 70 to 100. That is also known as 70%. So a fraction, as a fraction, 7/10 is equal to 7 over 10. So you got the decimal going to the fraction. That's nothing more than using language. 0 and 7/10, 7/10, and then you add a 0 to the end of both of them to get the 7/10 to be 70%. Pretty easy, isn't it? Let's move forward. Now what if the decimal is the last non-zero digit is in the hundredths place? Well, that makes it even easier. So here we have 0 and 34 hundredths, which you can rewrite as 34 hundredths. That's nothing more than understanding language. 34 hundredths is a decimal, is 34 over 100 as a fraction. And you're comparing a number to a percent, so that was going to be 34%. But I should point out that 34 over 100 is not simplest terms. And in middle school, we always have to be able to simplify our fractions. So let's take and look at that on our slate. So let's take a look over here. We have got 34, come on, give it to me. There we go. 34 over 100. And we have to show how we're simplifying our problem. The largest number that goes into both of them is 2. 2 goes into 34 17 times. 2 goes into 150 times. And that is where they got that number from. So the numbers we'd actually care about putting in is going to be 34 hundredths, 17 over 50, because that's a fraction in lowest terms, and 34%. Those are the three numbers we care about there for final answers. Now things are getting really exciting because now we're going to go to numbers that are in the thousands place. We have 3 decimal places here, 0 and 125 thousandths. You read the decimal number, then you write it down. 125 over 1,000. 125 thousandths is 125 over 1,000. There, you have it as a fraction. The fraction is not lowest terms. They're going to do their chicka chicka boom boom math and get this 1 over 8. We're going to talk about that. We don't do chicka chicka boom boom math. We have to justify it. They also did chicka chicka boom boom and all of a sudden had this 12.5%. Let's look at what happened there. Now, going over to the first part, what they did is they took and bounced a decimal, and I will let you do this. They took the decimals on the end. You have a decimal here and a decimal here. The decimal on that one, they bounced in 1. The decimal on this one, they bounced in 1. And now what do they have? 12.5 over 100, and that is where they got that number from. That, of course, gives them 12.5%. As far as the 1/8, where did that come from? Well, let's take a look. They took the 125 over 1,000 and they said, what's the largest number that will divide into both of those? And it turns out that number is 125. Now odds are you wouldn't figure that out right off the top. You would maybe have to do 5 and then 5 again or something of that nature. But they recognized that it was indeed 125. So they took the 125, divided top and bottom, got 1 over 8, and that is where they got that answer. So the 3 answers that you'd be looking for is the 1 over 8, the problem it started with, 0 and 125 thousandths, and the percent value of 12.5%. This part right here, the 125 over 1,000, that is just a bump in the road. This is your supporting work to get you to your answer. Now let's move through some slides here and figure this one out. They gave us 0 and 25 thousandths, which they successfully wrote, as you can see right here, whoops, too far, as 25 over 1,000. But we don't need to work at it from that angle. We're going to take and keep going from here. They took and did the loop-de-loop thing I showed you earlier, where they did a bounce in the decimal on the top and the bottom one space, and that gave them the 2.5 over 100. So now they can say that 25 thousandths is the same thing as 2.5%. That's a good start. Next, they want to be able to write it as a fraction. So how do they write it as a fraction? Well, they did chicka chicka boom boom math. We don't like that. Let's see how it actually worked. First, they took, and get my pen here, took the decimal that was here, and they went badoom, and they went badoom, and that is where they came up with that answer right there. But where did that 1 over 40 come from? Well, to get the 1 over 40, we're going to go back to the 25 over 1,000, and they're going to say, well, what is the biggest number that's going to divide into both of those? And that answer is going to be, whoops, I wrote that wrong. That answer is going to be 25. 25 divided by 25 is 1. 25 divided by 1,000 is 40. And that is where they got that 1 over 40 answer that you see right there. Hitting our next slide button, 0.025 is the same thing as saying, what did we come up with? 2.5%. And as a fraction, it is 1 over 40. Our answer checks. Let's keep moving. Now it's going to be your turn. I want you to pause the video, write this value as a percent and as a fraction. Be careful. Show your work. Good luck. See what you can do. Now I'm going to show you the way I would do it. It might or might not line up with the way the textbook would do it, but let's take a look. First off, I'm going to convert this to a fraction. So in the fraction, I'm going to say, well, 5 and 46 hundredths is, oops, let me get my pen going here, 5 and 46 over 100. Now they may make that 546 over 100. I don't see any point in doing that. From here, I'm going to take and divide the top and bottom number of 46 over 100 by the largest number that will divide into both of them, which I think is going to be 2. That's going to give me 5 and 4, I'm sorry, not 43. That's going to give me 5 and 23 over 50. So there I have my fraction in simplest terms, which is what I would put here, 5 and 23 over 50. They may require that as a mixed number. We're going to find out. I also have to do this as a percent. And as a percent, what I would be looking at here would be 500% for the 5 plus 46% for the 46 over 100. That means it is a 546% increase, so 546 will go right here. This is your supporting work. This is showing your work. This is what I must see before you put your answers in. Let's see if they're going to give me credit for what I did. I said 546 right here, and then for this one, it does want a fraction, so that's a good start. We've got 5 and what did I say? 23, whoops, over 50. Is that what I said? Let me look. Yep, 23 over 50, except check my answer. Woohoo! They did it in simplest terms and as a mixed number just like I did. Textbook authors must be as smart as me. It's been a while since we saw an apply problem, so let's see how this one goes. Write some real-world problems involving fractions, decimals, and percents. Watch the animation to find out. Here we go.
Allison monitored the percentage of time she spent studying some of her school subjects last week and made a table. She spent 13% of the total studying time on science, 11% on language, 20% on reading, and 16% on music. She wasn't sure how much time she spent on math and history. What fraction of the time was spent studying math and history?
Okay, well, she didn't know how much total time she spent on each one, but we can use this information to find out how much she spent studying the both of them combined. So, we've got the apply problem. This is one of those places that you get to pause the recording and do a whole lot of work. We're going to reread the problem several times. You're going to write down your approach. After you write down your approach, then you're going to actually solve the problem and check your answer. And finally, you are going to justify your answer in words to prove your work to me. Get started. Did you get it done? Well, how would I go about it? First off, in words. First, I will add up the percentage of time that she spent studying all the subjects that we know about. After I do that, then I will subtract that number from 100 to find out what percentage of time was spent on math and history combined. That is my plan. Of course, I need to hit the done part here. Yes, I'm done. And let's put our plan into motion. So, what do we know? We know science was, whoops, I thought I changed that already, 13%. Language was 11%. Reading was 20%, and music was 16%. I'm going to add those up. That's going to give me a 10, carry the 1. That's going to give me 1, 2, 3, 4, 5, 6. So 60% of her time was going to be spent on those 4 subjects. Now, how much is going to be spent on math and history combined? To find that out, we're going to take 100% total. We're going to subtract the 60% from that, and that's going to tell me that those 2 subjects combined, she spent 40% of her time on. So let's go back to our problem. And in our problem, we're going to type in the 40. Oops, 40%. Let's see what it did there. Let me see what here. She spent, hold on. I see. I did not read my question carefully. It said, what fraction of the time did she spend? So we need to change 40% into a fraction. So let's go back over here. That is, of course, going to become 40 over 100. I can divide top number and bottom number by 20 is going to be the biggest thing that will go into both of them. 20 goes into 42 times. 20 goes into 105 times, so 40% is going to equal to 2/5, which we're going to take and put in right here. Put our fraction button, 2 over 5, accept, check our answer, and we are the winner. Now, I just verbally explained mine to you. You need to be able to write down in words how you got to your answer. Now, based on this information, is it possible for you to find out what fraction of time Allison spent studying just math? The answer is no, because we'd have to know how much time she spent studying history. All we know is that math and history combined was 40%, so we'd have to know how much time was spent doing history in order to calculate how much time she spent doing math. Now we have one last problem for you to work here. Pause the video, work on this, see what you come up with for your final answer. Did you get it? Let's work on it together. Benito had 10 days vacation. He spent 1/5 of his vacation fishing. He spent 30% of his vacation at soccer camp. He spent the rest of his time on the beach. What percent of his vacation did he spend on his beach? Well, first we need to find out what percent 1/5 is. So to do that, I'm going to take and I'm going to say that, I'll get my marker going here, 1/5 times something over something equals something over 100. So of course 5 times 20 is 100. If I do it on the bottom, I have to do it on the top, giving me 20 over 100, also known as 20%. So right now I know that he spent 20% of his time fishing and 30% of his time at a soccer camp. That means he had 50% total there. It said he spent the rest of his time on the beach. So 100% minus 50% is equal to 50% of his time he spent laying out getting skin cancer and stuff on the beach. So right there is my supporting work. That is what I must see. If I see anything else, you will have done it just for fun. You have to give me good, high quality supporting work. Jump back over to the problem, submit my answer of 50%, check my answer, boom, everything's good. Now it's time for you guys to put a pencil on paper. Remember, when doing your homework tonight, you need to give me good, high quality supporting work so I can give you a good, high quality grade for your homework assignment. Good luck.